Hello, Dave Kimworthy here again. Today we're going to look at the short paper produced by Wildberger and Mansfield on Plimpton 322. They produced a short set of values from the original tablet, and these values have been amended over the years, and they identified the amendments. And this is a table of the amended values. It's called the root L table. And when I got this table, I started messing around with it because I realised that this column of values here, the 15 values, could be manipulated to produce imperial system values, and the second line 3, 4, 5, 6 can be divided by 6.48, and we get 533.333. That's the base 100 system. If we divide it by 100 and multiply it by 99, we get 528, which is a tenth of a mile. But these units aren't in imperial, they're just units. But the connection is obvious. They were using the imperial foot. There's no doubt about that. So this table tells us so much about what these people were doing and why they were doing it. And these values in green are the ones that the Australian professors told us had been recalculated. They were in error. And these are the corrected values, the amended values. This is the amended root L table. And what I wanted to do was to apply some fractional alterations to this table to produce a table of values that Thom was using. And that's this table here. And that's Thom's values divided by 11.6, and we get this table here, and then we multiply that table by 7. Now 11.666 is Berryman's Egyptian foot. I can't go into the mechanics of all this at the moment, but let's just say that I knew why I was using 11.666 at the time, but it's too complicated to explain it at the moment. But if you look at Berryman's book Historical Metrology, the Egyptian foot is 11.66 inches. Now, what I started to do was amend this table, which starts with 120, and it goes through all these values, and I wanted to produce values that I was working with at Stonehenge. And one of the values I was working with was 5.333. If we multiply that by 2.5, we get 13.333. I was very familiar with that value, and it's there. Now, to get that value, every number stated in this column has to be divided by 72. So you can see that this column here is this one divided by 72, and then we produce these values here that I was very familiar with. These are base 100 values. So that's what I've done with Plimpton there, and I've called it rebasing because we've got base 1 now in the Plimpton table, which is line 5. Line 6 is 5. Line 10 is 90, and we can start to see what we're working with, but the important value is line 11, where we're working with 60, and that translates to 0.833, because that is such an important unit. It's 10 divided by 12, so it's a translator from base 12 to base 10, and that we see all the time. And this is a table of base 100 values. And how do we get to base 100 in this table? Well, we multiply that and then by 2.5. So we know it's base 100. It can be adjusted to base 100. So we could have that value restated as 100. Now, the whole idea that I was working on was that Thom's value for the megalithic yard is 32.64, and that will translate divided by 34 times 33. We get 31.68. That column's not wide enough. 31.68. Now, what I realised as soon as I saw the megalithic yard is can be restated using 0.32 as a unit. So we divide it by 0.32. It's 102 units of 0.32, and we can do the same with this one. That's 99 units of 0.32. So that one's 102. So what's 100? It's obviously 32. So we can see how the system works. We've got the base 100 system in the middle of a base 102 and a base 99. Now, I wanted to state these Plimpton values that I've got here. I wanted to restate them against this base unit that I'm working with here of 1.66, but I've changed it to 16.66. That's the base unit, and that's base 100. So I'm changing that to base 99 by dividing by 100 times by 99, and we get 16.5, which is the imperial rod of 16.5 feet. If we do the same to 102, we get 17, and that's the Thom rod, although it isn't, because Thom calls the rod 68 units, and that's 17. So that's a quarter of a Thom rod. So Thom didn't quite get his notation right, but it doesn't matter. So what we've got here is this is Plimpton. This is the imperial system coming down to 528 there and 660. And this is Thom's system. So we've got Plimpton, imperial, and Thom. Now what we're looking at is this line here. We get to 40 units. We've got 660 in imperial and 680 in Thom. And we know that the saros plus is 6,600 days and the nodal cycle is 6,800 days. So we can see how the Plimpton table can be amended to find these values. And another thing that I discovered at the Aubrey circle is that they were manipulating pi. And the pi unit that goes with this column, the base 100 column, is 31416 divided by 10,000. 31416 divided by 10,000. It's there, 31416 divided by 10,000. That's the base 100. This is the base 102, 408 over 130, which is 3.138462. That's Thom pi. So it's in that column there. And then the other one is 22 over 7, which goes with the imperial system, and it's there. So we've got 100 is the Plimpton 322 base system here, and it's produced by this column, simply by dividing all these by 72. This is the original amended table that Mansfield and Wildberger are working with. And we can amend it here. But the ancient manipulation of pi is so important at Stonehenge because the Aubrey circle is 897.6 feet. If we multiply by 3.5, we get 31416. There it is. That version of pi is in 8976. So all we have to do is use a unit of 1 over 3.5 and divide it into 897.6. That's what they were doing. So we could go plus 1 divided by 3.5. We get this unit of 28571. We take that and divide by that. We get 31416. That's the way they were doing. That's the way they were working. It's called inversion. So instead of multiplying by 3.5, you're dividing by 1 over 3.5, which is the way the Babylonians did it. There's no doubt about that either. So here we have this solid evidence from this Babylonian clay tablet, and it's easy to convert it to what's happening at the Aubrey circle once we understand. And by doing that, we realise that there are 3 values of pi being used, and they're all related. So this one, Thom pi, 408 over 130, multiplied by 1.001 gives 3.1416 exactly, which is 31416 divided by 10,000. And that is 1,000 divided by 9996, and we multiply 3.1416 by that, and we get that. It's obviously deliberate manipulation of pi. And to be quite honest, I don't think these people really thought about what pi was. I think they realised they couldn't hit it. So they were quite happy to have it between boundaries. The boundaries at the Aubrey circle are this version and this version. And pi is somewhere in between. And they were happy with 31416 because that's a great fractional workable value of pi. And any engineer will tell you that. It's still a good version today. So that's what's happening. Now, what else have I done down here? I've said once this rebasing has taken place, the analysis leads to a translation into a version of the imperial system that needs to be rebased a second time to identify 528 times 10 as the imperial mile. So this is the rebased 1 over 72 table. And I've multiplied it by 22. And I get this table. And I get this unit here, which is the eclipse unit. And this is all coming from Plimpton. And this is what Mansfield and Wildberger were telling us when they produced their analysis. It's so complicated and it's so complex, and it's going to give us an insight into different systems of analysis that might have benefit for what we're doing today. Now, this system is so complicated and so complex, it's hard to imagine that it could have been produced by our ancient ancestors, and the only way we know that they were doing this is because of the work of Alexander Thom. He tells us what they were doing. He tells us they were using pi as 3.125. He tells us they were using pi as 22 over 7. He tells us they were using pi as 3.1416. And yet we choose to ignore this evidence, and we continue to speculate about what Stonehenge is about, when in the 1960s all the professors of the time were telling us, all the significant professors were telling us, it's an eclipse prediction device. Now, if it can be shown to be an eclipse prediction device, which it was done, then surely the mathematics that Thom discovered in the Aubrey circle will be able to predict eclipses, and it can. And the way that I've taken this further is by using the ancient barleycorn, because that's the unit of expression that these people were using. And we can see here the barleycorn is 0.3666. It's 11 over 30. It's 1 second in Babylonian time. And we're talking out the distance between Old Sarum and Stonehenge being 6 miles. Well, when it is, when we're using that unit, we multiply it by 60, we get 22. We multiply it by 60 again, we get 1320. Multiply it by 24, we get 31680. That's 6 miles in feet. And this is Plimpton 322. This is the most solid piece of evidence to suggest that the people that were designing these numerical systems are the people that Thom was writing about in his books, and the people that Howard Crowhurst is working on in France at Carnac. and he's producing this fantastic evidence to show what they were doing. They were manipulating route 2, route 3 and route 5. They were hyper accurate in their measurements, and they'd located true north in their designs. Okay, that's enough for today. Thank you.